Now, where we finished off yesterday is we were looking at a triangle, 30 degrees, 12, 15. And we had a triangle set up something like this here. They weren't the exact numbers, but we realized if we have an angle in the middle of two sides, we can't use law of sines. It just doesn't work. So what we have is something called law of cosines. Is what we're going to need to be able to solve this and one other type. Now, law of cosines comes in three different forms. But when we start looking at these three forms, you'll notice a pattern to them. A squared is equal to b squared plus c squared minus 2bc cosine of a. Or b squared is equal to a squared plus c squared minus 2ac cosine of b. And c squared. Huh? No. But if we look at all of these three here, the first one, a squared, a, the side that is by itself, angle A is in cosine. A and A. Let's get a highlighter out. There's A and cosine of A. B, C, and C. Because whatever side is on the outside, that angle opposite is what's going to be inside a cosine. So all three of these here are a similar formula. It's just we're switching out the values of A, B, and C. We're switching those places. So if I want to find side length A, I can use A squared is equal to B squared plus C squared minus 2BC cosine of A. And we're plugging in the values for these here. Well, let's go on and just look at this here, because once we start using this formula, it's going to make a little more sense. It's not going to be as scary. So when we look at this here, we're given two sides and an angle. So we're trying to find side length B and then angle A or angle C. So in this here, we're unfortunately to find one of the angles, we're going to have to use the value of B. There's just no other way around it. So we'll have to use a decimal side length. So if I want to find side length B, according to our formula, B squared is equal to A squared plus C squared minus 2AC cosine of B. So this here is our formula, the one we're going to want to use. Well, B, we don't know the value of B, but we know A and C, the other two lengths. A would be, huh? So we can say A is 11. So we can put that in as 11 squared. Try writing that a little better. And C is 14. Minus 2 times A, which is 11, times C, which is 14, times cosine of B, which is 34. So any questions on anything we've done so far? So pretty much we're wanting to find side length B. We picked that formula, plugged in for A, C, and angle B, and we got this here, yes? Now we could type this into the calculator, but is B by itself? No, we have B what? Squared. How can I get rid of a square? I can square root it, right? Well, if I square root one side, I've got to square root the other. So we can take the square root of both sides, and the square root of B squared would give us B. Now on the other side, we're going to have the square root of 11 squared plus 14 squared minus 2 times 11 times 14 times cosine of 34. And as nasty as that thing looks, what can we do? We can type all of that into the calculator, yes? We don't actually have to calculate any of that by hand. Let's do 13.75. Let's go 2 decimal places. 75 what? 9, so 76. Do we agree with that there? Yes?
And that's what I got.
The angle is. That's weird. What did y'all get? 7.85? 7.85. Okay, yes. Okay, 7.85.
Typing it again. Oh my gosh.
Yep.
I don't know what it did.
You're good. Questions on this here?
Yes.
Yes.
What's the difference between those two? Is that the exact same thing?
This here and this one here?
Yeah.
Yeah, they're the same thing.
Okay.
I just rewrote it because this step we took the square root of both sides, so this became v. And because that's not easily just, we can just take the square root, I just rewrote it.
Just take the exponent off.
Right, because the square root of b squared is just b. Yeah, and we'll get into more in depth why this works the way it does in Algebra 2 when we go over rational exponents. And there's a reason behind it. But the square root of b squared is just b. And so we have this length, 7.85. So any questions on this here so far? Are we good with this here? Yes. So is this formula as scary as you thought it was? Well, not really, once we just plug the numbers in and then solve. Okay. Now we need to find a side length. Or not a side length, an angle. Because once we find one of the angles, we can find the other, because any 3 angles in a triangle add up to be 180. Now there is a way to use law of cosines to find a missing angle, but we're not going to cover that today. We'll cover that tomorrow. But what we do know, we do have another way to find the angle. Because we can go back to law of sines, what we did yesterday to find missing angles. We can say A, and we will need sine of 34. Now there's nothing wrong with doing sine of 34 first. But I like putting the variable first. So sine of A over 11, because 11 is opposite angle A. Then we'd have sine of 34 over 7.85. Now we have to use 7.85 because there's no other way to set this up to be able to solve for a missing angle. Then what do we do next? We multiply both sides by 11. Right, so you would have 11 sine of 34 over our 7.85, yes? Is what's inside. And now to get A by itself and what you're saying, we have to take sine inverse of both sides. Not at all. Which gives us what? 5.8. Let's go, yeah, if we can do 5.9. Is everybody still good with that there? Yes? Because this here is what we did yesterday to find the missing angles. Awesome. 51.59. So we found angle A as 51.59. We found side length B as 7.85. Now we just need to find angle C. Now again, all three angles add together to be 180. So we can do 34 plus 51.59. If we add those together, we get 85.59. Let's write 180 first. .59. And if we subtract this, we'll get 414. Nope, too low. .9441 would be angle C. Yes. Let's see here. Did I add those two together wrong? 59 point. Okay. What do we get? 51.59. Yep. 85.59.
95.
95. Yep.
94.2.
I think, okay, as long as that's what you got for the angle, that's fine. It's 5.9, not. Yeah. Yeah, you're good. So any other questions on this here? We good with these here? So a lot of this, even though this looked as scary as it did, it's just a lot of just manipulating and using these formulas. All right, we'll do one more, because I feel like doing two of these, y'all feel comfortable with most of these, yes? For the most part, once you get a little bit of work with it, then it makes a little more sense.
Yeah, I still have trouble figuring out when it's cosine. It's not all that nonsense.
Right, so let's actually look at that. So law of cosines is going to be useful when we are given side, angle, side. We're given two side lengths and an angle in the middle. Now the other case we haven't talked about yet is if we are given three side lengths. Because with law of sines, I need really two sides and an angle. Now law of sines is useful if I'm given side-side angle, or let's see here, side-side angle, or angle side angle. Because either one of these two here, we would have two angles and a side opposite one of them, and we can find the others. Or angle, angle, side. So if we're given one of these three setups, two sides and an angle following it, two angles and a side in the middle, or two sides and an angle following it, we would use law of sines. Either our sine of A over A is equal to sine of B over B is equal to sine of C over C, or A over sine of A is equal to B over sine of B is equal to C over sine of C, whatever we're trying to solve for. And we have these set up here. Questions on this here? I know you weren't wondering this, but let's just say you were. There is such thing called law of tangents. There is a law of tangents. But anything that you can do and solve with law of tangents, you can actually solve with law of cosines. It doesn't make a really big difference. And it's really A minus B over A plus B is equal to, and it's right up here, tangent of 1/2 of angle A minus angle B over tangent of 1/2 angle A plus angle B. And for this here, if you remember doing systems of equations, x plus y equals 4 and 2x minus 3y equals 7. Stuff like this here where you had to find the value of x first and then found the value of y by graphing, substitution, elimination. That's what we would have to do with law of tangents. But it doesn't really add anything more than what we could actually do with law of sines or cosines. Not a real whole lot of point to it. But it is possible to do it. Okay, let's look at this one here. Well, for us to be able to do anything, we need to find the value of B. Yep, we're good. Yeah, for some reason it'll disappear from the screen. Actually, that might be helpful. So, trying to find B. And really, for any of these here, it's almost the missing side length squared is equal to the other two squared minus 2 AB cosine of our angle. There's the one that we want to find and its angle, and then the others are plugged in the middle. So we would have that B squared is equal to (3 squared) minus 2 times 45 times 43 cosine of 88. So really whatever side length we're missing, it could be A or B. It's really one of the other side lengths squared plus the other side length squared minus 2 times those side lengths times cosine of the angle. Okay. Now, we would square root both sides because the square root and square would simplify, giving us B is equal to the square root of 45 squared plus 43 squared minus 2 times 45 times 43 cosine of 88. We type that all in, we get 61.416. 14. Yeah. So 61.15. Okay. So we got side length B, 1.15. Now we need to find angle A and angle C. Really, I just need to find one of the two angles, because once we have 2 out of the 3 angles in a triangle, we know that they all add up to be 180. Pretty good. Now, do we want to find angle A or angle C first? C, so we can take sine of C over what? On bottom here would be 43, because it's the side length opposite angle C. Now the side length opposite angle 88 is 61.15. And I'm going to go on and write the steps out, because the first thing we're going to do is multiply both sides by 43, because the 43 and 43 would cancel, leaving us with sine of C is equal to 43 sine of 88 over 61.15. Yes, and then we have to take sine inverse of both sides. All right. I'm going to have to ask for that again here in a second. 1 second. Because then we would take sine inverse of both sides. Give us this here. Okay. Or 44.65. And now we know that all 3 angles add up to be 180, so we can set 88 plus 44.65 and add these together. And if we add these two together in the calculator, we should get 132.65, yes? And then we can subtract this from 180. So if we subtracted this from 180, well, I know that 5 added to here would give us a 1, which would make that 6 into a 7. And if I add 3 to 7, well, that makes it into a whole number. What I'm doing is, this is how I would do it in my head when I add or subtract, or kind of doing the grades when I grade y'all's tests, is I look at it and try to add back up to it. Because if I add 5, I get 7. 7 to 3 brings over a 1. Well, this 2 is now a 3, and I'm trying to get it to a 0, so I would add a 7, which would turn this into a 4. And what do I need to do to 4 to get to 8? So 47.35. So it's just going to the next 0 and calculating it up. So our other angle A is 40. Teaching it? This is my 6th year teaching it.
How long do you have college for?
4.5 years. As they said, and I can't remember the guy's name, but they say to become proficient or kind of become an expert at anything, you need to put in 10,000 hours into whatever it is. So professional athletes and whatnot spend 10,000 hours doing what they do to become, no, just in your lifetime. Because if you spend 10,000 hours doing anything over the course of your lifetime, you'll become proficient at it. You'll become good at it. And they've found that to be kind of the threshold of really becoming adequate to being an expert. I don't think I've gotten that far yet. I might be getting close. Are there any other questions on any of this here? Okay.